All right. Oh, my mic's quiet. Hang on. There we go. Something like that, probably. There we go. Hello, hello. I might turn it up a little more. Hello, hello. Test. Okay, now it's getting towards the yellow. That seems a little better. Hello, everyone. Just wanted a Ferris chain. Yep, I see you all having your fun there. Oh, and what the heck? I also see YouTube's like retracting all the messages. What the heck? Oh. If YouTube chat's being weird, let me know. It's like, can I show this without leaking too much? Yeah, on like my screen where I've got chat and stuff, it's just got a whole bunch of like message retracted. So if it's doing something weird, just no, that was us deleting them to try. Oh, okay, yes, very clever. I see. The camera lighting makes me look like I've gone through hell and back. Am I looking like pretty red? Yeah, that would be unsurprising. I don't actually know. I can turn this on. Hang on. I don't know if that's going to help too much, but it's there. Me after assignment 1. All right. So, welcome back to the grind. I hope we had I've heard it being called, well, I know it as flexibility week. I hope we had a flexible flexibility week. People were calling it, some people were calling it recharge week. I'm not sure if that's a staff thing or if they're like rebranding it or not. I don't really know what's going on, but regardless, I hope you had an all right time. Catch up on sleep week. I hope you had a relatively good catch up on sleep week. And yes, I've definitely heard a lot of people calling it assignment week. Yes. Reminders in terms of like the course and stuff. Where have I got this open? I'll just make a new one. In terms of the course and stuff, a reminder that assignment 1 is due here. Week 7 Wednesday. It's now officially week 7. So 2 days this Wednesday at 5 p.m. So just an hour before the lecture starts is when assignment 1 is due. The week 5 weekly exercises, usually these would be due, like usually it's the 1 week after a release on the Wednesday. But we were nice and we gave you till week 7 Wednesday instead of the week 6 Wednesday, so it wasn't due in flex week. So reminder that your week 5 exercises are going to be due also on Wednesday. The week 7 exercises have been released. I think there's a note about the auto tests for a couple exercises still coming. The macros exercises, auto tests are still coming. We're back to normal. We have our lectures, we have our workshops, and we have more weekly exercises on the way. A reminder as well that, this is week 7 exercises just been released, and then there'll only be the week 8 and 9 exercises, because week 10 we give you a prac exam instead, and that's obviously not marked. It wouldn't really be great to mark you on the actual exam and also a practice exam. So you've got 3 weeks worth of marked weekly exercises left. So yeah, we're getting towards the tail end of things for sure. What else did I want to say? So in terms of like random course to do things, marking, like as in weekly exercise marking, should be entirely caught up on. So notably, week 5 exercises aren't due yet. So everything week 4 and backwards, including all the manual marking, I think should be done now. And it should be accessible if our infra didn't go a bit sad. So check up if you're like seeing like marks are missing or something looks wrong. It's almost certainly not your fault. Just let us know if you think anything looks wrong, and it's probably on our end. But yeah, all the week 1 through 4 stuff should be marked now. What else have we got? Emails to the course account. All of those should have like been followed up on. If you've sent an email to the course account that you think that you believe has not been followed up on, or you're waiting for a response on, just bump it again. Again, don't be shy to throw in like a caps lock important if you think we've missed an email from you. Like ideally not just like the first time you're sending the email, but if you think we've missed something, then get our attention about it. But I think we should be all caught up there. And the forum as well. Anything that's posted, previously to today, should have been caught up on, and some, like half of the stuff today has already been caught up on. I know there's a couple questions that are still yet to be followed up on today, but sometimes it takes a couple days to catch up on things on the forum. Why is the internet dropping out? Well, what I was about to say is that I'm on the NBN finally. Hooray. So the internet should be way more stable, but then I just watched it drop to 0 kilobit per second for like 1 second. So I don't know if it may have been short enough that you didn't even notice a hitch in the stream, but great. The fun continues, it seems. It's not it's HFT. So, sorry, HFT. I've been talking to Tom too much. HFC, rather. 1 second buffer. Yeah. But sadly, I'm on Wi-Fi. The new house does not have Ethernet wired throughout the house. Keep an eye. If the stream starts buffering, you best believe I'm going to start running Ethernet cables across doors for next lecture. But we'll see how we go for today, and we'll press on regardless. So catch up on the chat. Is assignment 2 going to be similar to assignment 1? Right. That's another thing I should mention. Assignment 2 should be coming out most likely either very late this week or very early next week. So probably like if things go spectacularly, which is not particularly likely, then you might see it as early as Friday. I would be expecting something more like Sunday/week 8 Monday as a release for assignment 2, and that'll be due week 10 Friday is what I believe we've given you the due date as. Assignment 2 is going to be, workload wise, the workload is going to be different for everyone. My expectation is that the workload on these assignments is relatively high. Part of that being that they're like a relatively significant weighting in terms of like how we mark the course and stuff. We only have a 35% final exam, right? A lot of courses might do like 10% for weekly exercises, then 15 and 20 and stuff like that for assignments, and have a bigger final exam. We opted to put more marks here, so you can probably expect, more workload here. So yeah, I would call both our assignments likely to be relatively high workload, but everyone's going to have their own experience. You might find it easier, you might find it harder personally. What I can say is that it's still going to be focused, not, how do I say? Assignment 1 was very focused on design, quite specifically. But it's a big part of that is because there wasn't, getting to week 5 in a certain sense very much is sort of like coming up to speed with Rust. Rust, again, as I've probably attested to about 400 times by this point, is a very tricky language to start learning. And so the scope for what we can get you to do in your assignments by the time you're at assignment 1 is rather slim. So we're sort of we put a heavy focus on design and how you choose to structure your program, as opposed to writing super duper complex programs, let's say. There's a lot of complexity still in just working around the Rust compiler, of course. That's what makes Rust a difficult language to be getting started with. But like the scope is smaller for that, so there's a heavier emphasis on design. Assignment 2, we are going to bring in concurrency. If you're super duper advanced, we're not talking about like coroutine slash continuation slash async await kind of concurrency. I would love to have that in the course. Of course, I would be thrilled to, but it's in Rust in particular, and especially Rust in its current state, is probably too much for this course. So instead, we just end up using like threads, standard like operating system threads, and no sort of special runtime or anything like that. But there is a lot that goes along with concurrency in terms of Rust. Concurrency is very much like a culmination of a whole bunch of ideas in this course and in Rust, in that like you've been having to deal with all these different things, but you may not have found that there's a huge amount of bugs that like Rust is preventing you from running into. Like there's probably still a reasonable amount, but like some of the more nuanced ideas around like ownership or mutability and that sort of stuff, you might go, okay, I can see that this could cause a bug if it, wasn't there in this case, but they're a little more few and far between. But once you bring concurrency into the picture, the rules all start to make a whole lot more sense, and it starts to like, it all sort of comes together, and you're like, right, I get why, this is like that and that's like this, because now I can have an entirely concurrent program. I can go from the single threaded code we've been writing and go concurrent, and everything will just sort of work, and the Rust compiler will make sure like it'll check all your code for, concurrency issues and that kind of thing through the same schemes as we've already learned. So that's assignment 2 is going to have a bigger focus on that and a smaller focus on design, still a focus on design, but we're bringing concurrency into the picture, and so we know that we can't necessarily keep things at exactly the same sort of expectation as before. Okay, Ethernet over Powerline? Absolutely not. I shall not. As with assignment 1, we'll learn most of what we'll need for assignment 2 at the end of this week then. End of next week. Next week we end up... Well, how do I say? Similar to assignment 1, when we release the assignment, you'll have enough to do like the first portion of it. And then the end of next week, once we've finished concurrency, you'll have the tools to do the rest of the assignment. But yeah, the first portion should be doable with the end of this week before the assignment's even released. Do we need any familiarity with how concurrency works? I haven't touched it before outside the most basic async await. I will be providing some background on concurrency. For students that have a reasonable background in concurrency, then you're probably okay. Like if you're I'll like explain once we get to that point the sort of requisites we're assuming here and what kind of things we're looking at, and each student is welcome to sort of self-assess that point. I'll provide some of my background, but I might go, here's like the baseline stuff that we expect, and some students might have to do a bit of like background reading in terms of that. And that's very nice of you, Dong. That's yes. 1521 is a nice course. Come join 1521 when I'm teaching it last term. No, but Andrew is also a fantastic lecturer, and the content on concurrency 1521 is also very fun. Okay. Is there anything else I wanted to say? Forums caught up on, marking's done, assignments coming out relatively soon, emails. I think that's mostly it. Yeah, we do concurrency 1521 these days. I sort of jerry-rigged it into the course a little bit, like a year ago or something like that. Okay. So, right. So, this week, we're talking about metaprogramming and functions. It's funny. Metaprogramming sounds, wow, that's scary. That's a big word, and sounds like a very scary topic. Functions, I know all about those. Those are really easy. We'll probably find that the metaprogramming's actually probably a little bit easier, and the functions can get a bit gnarly. If you're coming from a particularly PL-based background, if you've taken courses like 3161, you might find the functions portion more intuitive. Where we're going to be looking at metaprogramming today, and we'll look at functions on Wednesday. Cool. So, metaprogramming. Yes. Awesome. And yes, back in 2019, it was in 152.1 and it got sort of ripped to shreds a little bit over time. Yeah. Okay. Metaprogramming. Right. So, what is metaprogramming in the context of this course? Who's done any sort of metaprogramming or has any thoughts about what kind of things metaprogramming is about? Lecture chat. Does 6771 count? For sure. Yeah. There's C++ is a language that has all kinds of metaprogramming ideas built into it. It borrows the preprocessor mostly from C, and the preprocessor has sort of textual based metaprogramming abilities, and it also provides templates, and templates also provide all kinds of metaprogramming facilities. So that certainly counts. Python decorator superiority, yes. So fundamentally what metaprogramming is about is writing programs that produce, or let's say programs is maybe a little too broad here. Let's say like writing code that produces code, right? So usually we write code to produce like an effect, right? So like I write a code that writes printf hello world or println bang hello world so that it will print hello world to the screen. But this idea of metaprogramming is instead of code that, produces some effect or like does some task, we write code that produces different code, right? Produces new code. And then probably we end up running that code instead. So like, what are the benefits of metaprogramming in this sense? Well, it allows us, there's a few sort of different scenarios and use cases for metaprogramming, but it can definitely open up possibilities that aren't possible without it. I guess we might have had a hitch, but I think it looks okay. Buddy NVN. It's only preprocessor if it comes from the preprocessor region of France. Otherwise, it's just sparkling said. Yes, very good. So, okay, great. So, at the very simplest, the only sort of form of metaprogramming we're going to be looking at in this course is, it seems fine, is macros. So, this does not represent the sort of ceiling of metaprogramming. But macros are probably the most popular way people tend to interact with the idea of metaprogramming, the way people tend to metaprogram. And at its very core, a macro really is a function from code to code, right? So it takes in potentially some code. It might take in no code at all. That's an option. But most of the time, a macro will take in some bit of code, run something inside or do some, manipulations and spit out new code out the other side. So in terms of those use cases, there's three sort of primary ones we're going to look at. Macros are often used for convenience, right? Like this thing is rather annoying to do or I have to do it a lot. And there's not a easy way to do this. I end up needing a lot of boilerplate code. Macros can often come in and make things far more convenient. And often with that convenience can maybe come sometimes a bit of reliability as well, potentially. A bit of robustness in that if you're having to write the same boilerplate code over and over and over again, but it's potentially relatively easy to screw up writing that code. Having a macro that can only do it correctly might add a little bit of, a little bit of reliability to your overall program. But absolutely, they can also macros have a way of destroying a lot of reliability in the process in certain cases. So we'll look at some of that. Macros in some languages may often be used to simulate polymorphism. So we looked a lot at polymorphism in week 5. And the idea here is, well, we saw in Rust that programs are monomorphized, if we recall this. So the idea being new text file. If I have some function foo, which has a generic parameter t, right? And I call foo with an i32, and then I call foo with a float, and then I call foo with a string, all these different things. Essentially what the Rust compiler is going to do is it's going to go, well, I'm going to generate one version of foo for an i32, for an f32, for a string, and end up creating foo i32, foo f32, and foo string, for example. And then end up calling each of these when they're required. Macros are very good at spitting out lots of code, right? And so you can use macros to sort of do the monomorphization almost like yourself, where you go, okay, well, I'm going to generate the i32 one, the f32 one, the string one, so on and so forth, and go through this process manually yourself. You could imagine a macro that looks something like generate foo for the i32 type, for the f32 type, and for the string type, and these macros go ahead and spit out these, the actual function implementations themselves, like this. So it's something that we generally try and avoid in a language like Rust, because Rust has quite good support for polymorphism in the language itself. But it's certainly something that crops up in languages like C, for example, or potentially in languages like C++, if you consider C++ templates to be, you can sort of choose which side of the fence you lie on in terms of if you feel they're more macro-like or they're more polymorphic-like. But there's certainly a school of people who may tend to think that C++ templates, for example, are more macro-like than sort of having an incredibly rich type system behind it, potentially. And then something really interesting is this idea of syntax extension as well. So macros can help you almost create additional syntax in the language, potentially syntax that's more convenient, right? Or more clear than what you could achieve in the language otherwise. This may fall under convenience to a certain extent, but it's probably a bit of a deeper idea. With macros, you can do things as crazy as embedding other whole languages within another language's macros. And that can also open up more avenues for robustness and reliability. And we'll have a look at some of that towards the end. So, very interesting. Templates in C++ are dodgy enough to be macro-like, 900 lines of errors for a single typo. And it seems clear that I could take a good guess as to which side of the fence Miguel has decided to fall on there. So before we get started with macros in Rust, let's just have a look at a recap on what macros in C, and you could achieve similar results in C++ if you so chose to, but it's probably not so encouraged these days to use the C preprocessor in C++ too much. But regardless, in C, you'll often find the preprocessor having, being liberally used. Even in places like, I believe, like the Linux kernel uses C macros quite a bit for basically all of these, all of these use cases pop up one place or another, if I recall correctly. So let's start off with a very simple macro, which is the max macro. These examples were mostly stolen from from some Yale examples, except they had some a subset of particularly egregious bugs, which made the translations a bit fun. But anyway, so here's what we might see for like a max macro. So you may recall something like hash define my constant as 42 in C from, you know, say 1511 or you know, let me see. If you see my head like ducking down here, it's me looking past my speaker on my desk to try and check the bit rate, but it looks okay. So you may have seen this, and you can just sort of type in my constant somewhere, and it will end up replacing this with the exact text 42. So often people refer to this as constants, but it is actually a macro at the end of the day. I believe C refers to this as an object style macro or an object type macro, as opposed to a function type macro down here. But the naming isn't particularly important. But the interesting idea is that these macros can take arguments, if you haven't seen this before. So it says, instead of like writing max or whatever, instead you're going to write max with parens. It's going to take two arguments, A and B, and it says if A is greater than B, this is a ternary operator here, just saying if A is greater than B, then give back A, otherwise give back B. And so I call it down here, max of 1042, max of 3.14, 2.78, and I just print them out both down the bottom here. So let's see if this works. Clang max.c, and you'll see the maximum was 42, the maximum was 3.14. So this seemed to work. It's good news. But why did what's the advantage of this being a macro here, right? I'm going to explain some more things that's going on here naturally. But going to the chat here, what would have I had to have thought about if I chose to implement max here as a function instead of a macro? Like what are some potential, say, disadvantages to writing max as a function instead of a macro? So no function calling overhead, Dong says. Yeah, so if I wrote int max of int A, int B, or just return A is greater than B, question mark A, colon B, like this, there may end up being a little bit of overhead when we call this function, in that it needs to go away and make a function call and then come back. This can be avoided. Most compilers, when you tell it to optimize, will go LLVM in particular, which is the back end of Clang, which I tend to use as opposed to GCC, but even GCC as well. But particularly Clang or LLVM is famous for inlining everything it possibly can. In fact, there's a common joke that LLVM's heuristic for inlining is yes, and that a heuristic is sort of like let's say a condition that guides some kind of decision. Like maybe it's if the function is short, then inline. LLVM's heuristic for inlining is basically just yes. And so the function calling overhead is usually not too big a problem, but it definitely could be in certain circumstances. But yes as well. So the other thing to think about here is I had to write types. When I changed these max and max down here, we see that this one worked because I've given it integers, but now this one here doesn't work because it's working on floats. And so it's saying, hey, it's going to implicitly convert it. This would not compile in Rust because the types are very strong. They don't like to just be coerced around. Well, I mean, there are coercions, but they're usually pretty safe coercions. This is a lossy coercion going on here, which is a little scary. But then, yes, I would end up having to do something like max, int max, and then maybe a float max. And you can see where if I wanted to make a whole bunch of max functions in C, it could get rather tedious. So in this case, I don't need to generate a whole bunch of different functions. I could just write a single macro that works for any of these A's and B's. But you could imagine where you might want a macro to spit out a whole bunch of these implementations for you. We're going to see that with the sort program in a little bit there. One of the interesting ideas here is that there is no types in a macro, right? I didn't say A is an int and B is an int. I just said that these are things. And essentially what the C preprocessor is going to do is it's just going to like take the text here, 10 and 42, and just like substitute them in here, like this basically. B, sorry. It's going to take this code here and just spit it out right there. Like this is exactly how a macro works, the way I just did it there. And it'll just spit this code inline like that. There's a nice command you can use to don't actually run the program, just expand the macros, just run the C preprocessor, which is instead of compiling like normal, I can say clang-e, and you'll see here that's exactly what it's done. It's just taken this macro definition and modified this code, right? 3.14, 2.78, and you can see it down there as well. And thus it's sort of revealed why this code compiles as a macro but doesn't compile as a function. As a macro, it's just ending up as this code here. I can always do int is greater than int, and like set an int here. I can do float is greater than float. Like this operator here is the main sort of important one. And as long as I can do greater than or less than on that kind of type, then C will be happy with it. Things that it might not be happy with is something like a struct. But then like once the preprocessors run through it, and you've done max of my struct A, my struct B, it'll expand it. The compiler will run on this code and it'll go, hey, I don't know how to compare like these two structs here. And yes, as before, we don't we could actually tell the compiler explicitly to inline it as well, which I believe in C looks like this. In Rust it looks like this. Sort of hinting to the compiler, please inline this function always. So, okay, that's pretty interesting. And this has maybe like helped us in this particular case, the max macro. So let's immediately begin here with what can go wrong, right? Like this seems to be going relatively right. I very carefully wrote the macro to be like this as opposed to like let's say if I just did, A is greater than B, question mark A, colon B, like this. In this case, I'm trying to think. The max macro might be one that's a little more difficult to demonstrate these edge cases on. But I can certainly make another macro that demonstrates this problem. If I said, let's say, let's see. Yeah, let's say I had like an add, let's see. Which way? I want it this way around. I want to have multiply by 7 of some value x. And let's say I just turn this into x times 7, like that, right? This seems like a pretty innocent macro. Takes something x and then spits out x times 7. So then let's say I go int let's see, int my number equals multiply by 7, and in here I could give it 4. We'll double check that it works basically. Printf %d my number, like this, clang, run. 7, 4 times 7 is 28. That's great. So what if I do 2 plus 2 in here? Suddenly it's 16. Oh, so macros are immediately a little dangerous. How did this happen? If I go back to this tool here, which is saying just expand the macros for me, don't run the code, you'll see it did exactly what it was told to. X here is 2 plus 2. So, we got 2 plus 2 here. Great. I'm going to substitute that in for X. And then I'm going to take that code here and paste it down there. So my number is 2 plus 2 times 7, and snap, operator precedence comes into play. 2 times 7 has higher precedence than 2 plus 2. And so we get 2 times 7 is 14, plus the 2 here is 16. So a little dangerous. Now, how could we have fixed this? Well, an interesting way we could potentially do this is, what if I threw some parens in here? So instead of just doing a single set of parens, I'd do a double set of parens. you'll see I get 28 again. Why is that? Well, now the thing that gets substituted is this 2 plus 2 in parens, and so it ends up getting 2 plus 2 in brackets times 7. So that's pretty good. But I don't want the user to always have to remember they have to do double brackets every time they call a macro. So sometimes you might do something like this. Put the brackets up here so that whenever they use some x here, then it'll always make sure it's in its own set of parentheses, so we don't get any kind of operator precedence going on with this multiplication. And you'll see we get the same effect down here. Just with 2 plus 2, that gets substituted into these parens here, and then times 7. So that works. However, there's another problem that we might run into, which is what if I said like add 42 of x. And I've learnt my lesson. I'm going to put x in brackets now. And I'm going to say, actually 42 is probably a bit big. Let's do add 5. And I'm going to write x plus 5 like this. So then I'll say my number equals add 5. I'll zoom out a little bit so I can see a bit more of the program. Add 5 of the number 2. That should give us 7. And then I'm going to multiply that by 4. And I'll print it out. So it should be 28 as well. But mistake, it's 22. We look at the, the output to see what's happened here. Well, add 5 of 2 got turned into 2 in brackets plus 5, right? Like this. But then the multiply by 4 that I've got out here, right? This multiply by 4 just sort of gets spat right after it. And we've got operator precedence again on this plus 5. Right? Oh no. So again, similar sort of trick. We could throw parentheses around this whole thing. So we get the 2 plus 5 first and then multiply by 4. And naturally that does work. But I don't want everyone to remember they have to put brackets around my macro every time. So I can also put brackets around the whole thing. And then we still get the same result and the same expansion like this. So this whole set of examples here goes to show a couple of important ideas. You can now see why I've written it like this, by the way. Anytime I've used the token here, I've wrapped it in parentheses, and then around the whole thing I've wrapped that in parentheses. People tend to program very defensively when they're writing macros and just parenthesize everything to make sure nothing goes wrong. You might even get super paranoid and go, oh, I'm going to put this whole condition in parentheses and then, so on and so forth. But, you can never have enough, you can never have too many parentheses when you're writing macros in C naturally. But so it goes to show two things. One is macros can be tricky to write. They're a different way of writing code, and they come with their own sort of gotchas and pitfalls and things to be careful about. But two, it also, I think, helps serve the reality of the fact that macros are about substituting bits of code around. They're not about they look like functions, but they're not quite like functions. A function is something that'll get called with well-defined values and stuff like that. And actual values, actual terms, whereas macros are really operating on syntax in code, right? They're really operating on not 2 plus 2 meaning 4, but number 2 plus number 2, those actual characters of code, that syntax of code ends up being what they work on. And so it's a very important idea to sort of think about. There is another thing that can go wrong with this max macro here, which Miguel has pointed out in the chat there, but I'm going to show it in a slightly different way. Imagine I had a function that was int print and return. It takes in some int x, it goes printf, the int is, %d is x, and then return x back. Right? Pretty, seemingly somewhat harmless function. If you're a functional programmer, you probably hate it, but that's all right. And then let's say in this max code here, I say print and return 10, and then print and return 42. Right? So if this is a function that I'm calling, if I'm calling a function max, you would imagine that this would print out the int is 10, print out the int is 42, and then it would call the function with 10 and 42. but we get something weird happen since we're working with macros. We see the int is 10, the int is 42, and the int is 42 once again. Right, that's strange. Why did that happen? Look at the macro output, and you'll see it literally substituted it code-wise, like text-wise, into this thing here. So you get print and return 10 is greater than print and return 42, then give back print and return 10 or print and return 42. So because it's, saying A, B, A, B, you end up like pasting this same code in all over the place. And so what happens is it goes, well, print and return 10, like when this code actually runs, it goes print and return 10, yeah, that's 10. Print and return 42, yeah, that's 42. 10 is not greater than 42, so we give back this branch here, which is the print and return 42 again. So it'll give back the value 42, but it ends up needing to print and return it again. And so that's another sort of like, tricky thing that can happen with this. And does this have anything to do with lazy and eager evaluation? In the normal sense, like it's definitely the same idea, in that this is like macros sort of almost act like very lazy. It's, I probably wouldn't say it's like, what's the right way of putting this here? Like it's not sort of, oh man, yeah, the word's sort of escaping me, and this computer is going crazy in the background. It's not like definitionally lazy in the normal sense, where say like a functional programmer might think of, lazy and eager, because it's not actually working as code in the program. It's just like substituting text, but it gives that effect of being very lazy, if that makes sense. Like it's in terms to say like it's probably a good way of thinking about it, but it's obviously like subtly different to the normal case, because it's working on like code and syntax and text, that kind of thing. Yeah, that's our sort of simple work into macros in C. So this was mainly like a convenience one, and also kind of like a little bit of polymorphism thrown in here, where we've made a macro that works with anything that can be compared like this, right? But it's not so heavily polymorphic in that it's defining its own functions. It's mainly for convenience. Oh, I see. So yes, I'm thinking of it in terms of like closures and stuff, sort of like where it's quite like literally defined, I suppose. But it's definitely like the same feeling, the same idea. Absolutely. Right. And so we'll look at polymorphism a little bit more closely with this sort example here, but there's also this idea of syntax extension. And I've got an example here with this up to. So imagine you don't like the C for loop syntax, where you always have to write like for int I equals 0, I is less than 10, I plus plus, like that. And you go, well, I always do I is 0 and, less than some number and plus plus. I want to automate that stuff away. You could like make up your own syntax, right? So this is an up to macro. I define int I and 10 here, which are the important parts of this for loop, and also the body of it. And this sort of gives me new opportunities of expressing different ideas in the language. So how did I define this macro? I said it takes a type, an I and an N. And remember, there's no like actual types here. I'm not saying like this is like a type, this is an identifier or whatever, or like, int, whatever. This is just like bits of code that I'm just saying, I want one bit of code, another bit of code, another bit of code. I'm calling them type I and N for my own sanity. But they could, you could call these anything. But I'm expecting a type to come first. They provide int, and that type gets substituted here. So we get for int. Then I say, give me like the name of the thing that you would like to use in the body, right? What are we iterating? What's the variable we're iterating over called? We could call this foo, and we'd have to change this foo down here in the body like that, let's say. And so it's going to substitute I here for foo. That becomes foo, that becomes foo, that becomes foo. And then finally we have what would you like to iterate up to here, which is n. And that's, we've just put in like substituted in 10 there. Notice this doesn't take the body though in this, in this code's case. And this is mostly because the C preprocessor is like really wacky it's like very permissive in the kind of crazy stuff it might let you do. And in this case, I've just sort of ended the macro off before the for loop even had a body to come after it. And I go, I'll just specify the body after the macro is done. So this macro ends up expanding into this part. And then, great, I've got a body right here to go with it. Right, and it just sort of like works. So if I go to, or if I clang up2.c and run it, you'll see the concrete version works. It prints out 0 to 9. But if I go back to like the macro here, there, I guess I'll call this foo for consistency's sake, you'll see that this still works, 0 through 9. Because again, and if we look at what it outputs, it literally outputs that for loop as we saw before. So this is a pretty tame example here. This is quite a tame example in terms of like defining additional syntax. And again, this ties into like ideas like convenience as well, for sure. But we're going to see in Rust later in the lecture that you can really scale these ideas up. In C, it might be a little more tricky with the preprocessor macro syntax. But the Rust macro syntax and how you can define macros goes a lot further than what the C preprocessor can allow you to do. And we're going to see that there's some really interesting ideas in terms of defining your own syntax that can be really impressive. Finally, we'll look at this like quite heavily polymorphic example. So what's going on with this? Oh my God. Let's do close others. So I've got the up2 still in here because, oh, cool, we'll still get to use this. But like if I just show you main here, like that, I've got an array of 10 numbers, pseudo randomly shuffled. And I say I want to sort this array of integers. There's, here's the array, there's 10 of them, and they're integers. And I say, print out the array, print out all the elements of the array. And most people, some people in C would know that generally the advice would be to use the qsort function in order to do this quicksort. Quicksort takes the array, the size of the array, the size of each individual type, and then a function that knows how to compare elements of the array, right? And this can be kind of tedious. Like if I want to say sort ints, sort floats, sort chars, then I end up having to repeat a whole bunch of the same code. So what if we made a macro that creates this int sort function for like whatever type you want? So like say declare sorts for float and float. Declare how to sort doubles, declare how to sort chars, right? All of this. And then magically we just have like float sort available to us. We can sort arrays of floats, or char sort, and now we can sort arrays of chars, right? And the way it achieves this is by defining this like hash syntax is essentially take the thing in the macro and like append its name with whatever comes next. So we're saying here like the prefix is int, so we're going to do int underscore sort, right? That's the name of it. Like I've got a void int underscore sort, takes in an int star, an array of integers, how long the array is, and calls qsort with this function here, declare sort, underscore declare sort underscore int underscore compare, which essentially just is like some slightly generic code here to compare two integers, right? If we look at the output of this, not up2, we're looking at sort now, right? This can get a little bit crazy, but you can see here it's defined this declare sort int compare, declare sort float compare, double compare, char compare, and then also these functions here, int sort, which just calls quicksort, the array, size of the array, however big an int is, and uses this function that it's created to compare the integers, or to compare the floats, or to compare the doubles, so on and so forth. And so you can sort of get the sense here that we're almost acting like Rust's monomorphizer ourselves, right? We're actually saying generate each of these implementations. This is really what the Rust compiler does when you use things like generic type parameters. So this kind of macro usage we tend to avoid for the most part in Rust because, again, we try and make use of what the language and the compiler has made available to us. But it's a valid use of macros that appears in the wild and is a important idea for for metaprogramming in general. And again, to be clear, this is really just like slinging bits of code around. These macros are also quite declarative. So declarative meaning we've basically said in C, here's the name of the macro, it takes in these bits and it spits out code that looks like this. And we just sort of like throw in, prefix, and we throw in type and all that, and it'll just like substitute the bits and pieces. Those are the kinds of macros we're going to look at in Rust, but there's also another class of macros called procedural macros. So I think I have some slides on this. Right. So declarative macros in general are meant to be sort of easy to write, easy to read, for some value of easy, have relatively simple semantics, but are sometimes limited in capability. So these are often called macros by example, in that you're saying like, here, if they call declare sort with a prefix and a type, spit out code that looks like this. And again, this is the kind of macros we'll be writing in this course. However, there's also procedural macros. Procedural macros. C doesn't really have a built-in equivalent for this. We often just call these proc-macros, by the way. But in Rust, it's fully fledged Rust code. You can write a whole Rust program whose only job is to take in a stream of tokens, like tokens in the language, and spit out different tokens in the language, right? Like, take in a 42 and then a plus sign, then a 120, and do some operations and spit out new code that will then be fed back into the Rust compiler. They're sometimes very difficult to write, and they're sometimes very difficult to read. However, they are extremely powerful and open up all kinds of crazy possibilities that we'll have a look at a couple examples in the end. So proc macros are definitely very cool. Let's do that. I apologize for like 1 pixel of space. There we go. Perfect. Cool. So yeah, what we've been looking at so far is declarative examples or macros by example. But it's worth knowing that there's also these ideas of procedural macros, which are like, again, a whole separate program that gets compiled and then run as your code is being compiled. And it feeds in your program's code to this other program. It runs, that program spits out a new token stream, and that gets spat back into your program. It's some very cool things that you can do with that. Okay. Cool. So we're going to look at how writing these kinds of macros in Rust works. In particular, we're going to try and remake the vecbang macro ourselves, because that's a pretty nice like getting started example that shows you most of the important ideas of macros. But we're like right up towards the hour, so I think it might be a good time to just see like, catch up with where we're at so far. Catch up with, how we're feeling, if there's any questions or anything like that, and then take a quick break, and then we'll write a bunch of Rust macros, and look at some very cool crates that do some very cool things with procedural macros as well at the end. So are there any questions, queries, comments, concerns from the chat before we have a little bit of a break? Or does anyone want to, put a crab emote in the chat so I know it's so I know the chat's not completely dead? All right, we've got a crab emote. All right, well, let's take a break now. I'll leave you all the break to think of if you've got any questions, and then I'll field however many there are after we come back from the break. So let's have a break until 19:04, we'll come back after the break, answer any questions, and then continue on with the rest of the content. So I'll see you at 7:04. All right. So it seems that there weren't any, well, lecture questions, I suppose, during the break. Apart from class run Sturek maybe not working, yeah, I'll just have to get you to make a post on the forums with the output and stuff. It's totally believable that things are naturally going wrong with it. But yeah, so yeah, I'm sure you know the drill. Throw it on the forum with some output and stuff, and we'll try and figure out what's going on. Otherwise, we shall continue on here and have a play with this macro rules vec. Very cool. So one thing I'm quickly gonna do. Yeah, one thing I'm gonna quickly do is I'm gonna copy paste this into main. Into main.rs, mainly because mainly because it plays better with a tool called cargo expand, which I'll show in a second. So yes, we would like to make the vec-bang macro. So if you recall, we have the vec-bang macro lets us do things like, I'm gonna have to comment it out, lets us do things like let my vec equals vec-bang of 1, 2, 3, 4, 5. Right. And if I print it out, print out my vec. Am I in the right spot? Nope. I guess it's here. Cargo run. I have a vec of 1, 2, 3, 4, 5. Right, it actually like constructs me in this case a vec of I32s. Great. And this also works for whatever type it is. Let's say a string's a bit bad. Let's say a vec of strings, where I might have hello world, it's me. Right, and this still just works. And it doesn't care how many parameters you give it as well. You could have an empty vector, and it's got nothing in it. You could have a vector with just one element, and it still works. And as we saw before, we can have a whole bunch of elements here, like hello world, it's me. But how does this work, right? How does this actually even work in the first place? Well, there is a brilliant tool that can give us a bit of insight here, called cargo expand. I was up yesterday working hard to get cargo expand working on CSE, and I am glad to say it should. I'd love to say it does, but I believe it should. So if you have problems with it, let me know. But in fact, all the 6991 tooling I did a big update to is yesterday or the day before, I can't really remember. So if anything like cargo or Rusty or whatever is not working properly for you, post on the forums, let us know. But you should be able to write code like this, 691 cargo expand. I'm just going to write cargo expand myself here without the 691 because I'm working locally. And you can just run it like this, cargo expand, or you can tell it a function in particular that you'd like to expand. But it appears that the function needs to be in the main.rs file. At least from my quick experience playing around with it. I didn't know about this option until Tom told me about it recently, to provide a function, but it only seems to work for me in main.rs, so you might have the same experience. But what cargo expand does is basically the exact same as what the Clang -E does. It runs the macros, right? Macro here, vec-bang, without actually running the code itself, without executing the code. Just show what the macro expands into. So you can see here the let my vec of @stir equals, all that stays the exact same, just like in C. But this macro invocation here, vec-bang of this stuff, got turned into this. Essentially, it got turned into something that creates a vec out of hello world, it's me. This is a bit of a sneaky and or tricky way to do it. We're not going to do it quite this way. When we write our vec macro, we'll do it a slightly simpler way, I believe. But this is the primary idea. Whenever you see an exclamation point in Rust, right, vec-bang here, you know that you're working with a function, not a macro. And note, I've done square brackets here, and most people tend to use square brackets, but you can actually use any of the 3 primary delimiters in Rust to delimitate a macro. So you could use parens here, or you could even use, braces, like such. And it's any of those can be used to delimitate macros. But yeah, this exclamation point in the name tells us we're working in a macro. This is not going to be called as an actual function. This is going to be substituted, worked on, and new code is going to be spat out. There's also other kinds of macros we've dealt with, which look maybe something like this. Struct foo, I don't know, something like that. Derive clone here is a macro that will generate some code that looks a little bit like this. Simple clone for foo, fn clone gives back a self where the string is self.string.clone, like that, with a comma instead. So hash derive clone will essentially spit out this exact code here automatically for you. And in fact, cargo expand should be able to give us this as well. No, but it doesn't show me on. I'm going to get all the code out. I'll see if I can. Oh, here we go. That's all right. So you can see here, it spat out this code here. It spat the, the struct foo stayed. That was okay. But it also spat out this impl clone for foo, which just says in order to clone it, you need to create a new foo where the string is the self string cloned as well. And so this is also a macro working on your code. This one here is mainly for convenience because it's kind of annoying to write out all these very simple derivations over and over. And there's also attribute macros as well, where you can get code that will, modify, say, a function or like a struct or whatever, that isn't derive in particular. The most common ones are things like web frameworks. You might have something like my route that, has some stuff in here and does some stuff there. And you might say like, get slash, hello, or I don't, I'm just coming up with random stuff here. And this might spit out a whole bunch of extra code in order to make your function here, or it might even modify the function itself in order to make it suitable to use in your web framework. If you've, done 1531 or something like that, you're probably familiar with this kind of idea. And so there's all kinds of different macros that, swim around in Rust. But again, the main ones, the only ones we're going to get you to implement are declarative macros by example, and not procedural, and pretty much just in this flavor here with the like thing bang as opposed to attribute macros that work like this, or like derive macros, because these macros here you can't do by example. These are only procedural. Which means that it actually runs some code again to spit out different or more code or anything like that. So declarative macros instead is what we're looking at. And I've commented it out here. And this is like sort of baby's first macro that we've got going on here. Let me figure out what I want to leave here. That seems reasonable. Yep. So baby's first macro we've got is just macro rules bang vec. So you write the text, this is blessed text here, macro underscore rules bang, right? If you're creating a new macro by example, a new declarative macro, then you got to start with this blessed text here, macro rules. And this is, some people tend to think this is like, this macro rules, this macro is the best. It's actually saying more like these are the rules of the macro, which we're going to see in a minute. And then give your macro a name. In our case, I'm naming the macro vec. And then some braces to delimitate the entire definition of this vec macro, and then rules. These are the rules here. So I can have as many rules as I like in my macro, and they essentially say, when the code that's passed inside the macro, when the tokens, the syntax, right, that's passed to this macro look like this, like whatever's inside these parentheses here, right, this stuff, then spit out this code instead. So the first rule is already like done for us here. If no code is provided, so this would be the case that looks like vec bang of nothing inside it, then simply spit out a new vec, right? With no elements. That seems pretty reasonable, right? That makes sense, I think. And let's see it in action. If I go here, let's get rid of all the test cases for now. Let my vec equals vec bang of nothing. It doesn't know what type it is though. Let's say it's a vec of integers. And I say cargo expand test vec. You'll see here, this vec bang of nothing turns into vec new, right? Fantastic. And again, the way it did that is it saw, well, there's nothing in here. There's nothing in here. These match. And therefore I'm going to spit out vec new. Just like a match expression as well. Very similar idea. But then we might want to say that they can actually, provide some elements that they'd like in the vec. Let's just start off with one element to get us started. So let's say we're going to say like they can give us an item. And then I would like to say, okay, you know, this macro, what is this macro going to like turn into? It's kind of a bit of a tricky idea, right? Because they've written my vec equals this. So like, I can't really just say like, let mute vec equals vec new, vec dot push the item, and then you know, I guess they have the vec here. Like this just doesn't really work. If we expand it, well, if I actually like pass an item in, we're going to see for the first reason, it doesn't know what this 1, 2, 3 is. I'm going to skip ahead here, just like avert your eyes for a second, right? Imagine that was the same thing we'll talk about in a second. We're going to see trailing semicolon, let express. Yeah, okay. It won't even expand the vec for me. I was hoping it would expand it and we'd see it's wrong, but it's like, it's so wrong. Oh no, there it is. Great. No, it is there. Great. Ignore all the massive error at the top. We get let my vec is a vec of i32 equal to, like, let mute vec equals vec new. Like, it's not like really working, right? Like that doesn't really make sense as Rust code. So let's think about how, if someone gave us vec of 1, 2, 3, oops, what would we want this to turn into, right? Like, how could we go from this into the code that we want? So this is the way I often like to write macros when I'm writing Rust, is here's like my case here. What should the code that the macro spit out look like? And if you need to define a vec right here that includes the element 1, 2, 3 without obviously using the vec macro that exists, how would you do that? And there is a trick you can use here. You can use that idea of blocks in Rust and blocks returning an expression implicitly and that kind of idea. So how would I do that? Well, I'd say first spit out some new braces, and in there I'll say let mute vec equals a new vector, and then say vec dot push the item, which is 1, 2, 3, and then give the vec back as an expression at the very end here. So this is a block that'll end up evaluating into this expression here, the vec, and so it'll set that to be that. And this is, oops, what have I clicked here? And this is something that we could spit out, and it should, in theory, do the right thing. So how we tell our macro to do that? Well, the important idea here is we didn't actually tell it to spit out these braces, right? By default, it's just going to like put the code right there. So I'm going to need to start off by saying, hey, I actually need you to create a block here. Right, so inside this expansion, create a new block that it will spit out, and then give that vec back as an expression at the end. Right, and if I go, let's forget about this code for now. Let's see what this now expands into. You'll see it expands into equals brace, let mute vec is vec new, vec.push 1, 2, 3, vec. Right? Great. Now there was a little trick that I said, look, avert your eyes for a second. I'm going to tell you about this now. In C, we would just write item like this, right? Item, vec, push item, great. And it works. But this doesn't work in Rust. No rules expected the token 1, 2, 3. Maybe we can have a look at the error message now, right? No rules expected this token 1, 2, 3. So what's going on here is that in Rust, in C, you can just sort of like define parameters that it takes in and, separate it with things like commas or whatever, item, foo, bar, whatever. And these are all parameters. In Rust, you can actually say, like when I write item by default here, it's literally going to look for someone typing in the code ITEM, comma, right? Like it's actually looking to match this exact syntax here. So I'll show you, if I write item foo bar into this, then it will work because it matches that rule, and then it'll turn into, this with, again, the literal word item. I told it to type out the literal word item, and it'll go, hey, I don't know what the value item is, right? So Rust expects like the exact syntax in these declarative macros like this. So that's the first thing that we sort of run into. And then, so like, but macros, if you can only get them to spit out code, you can't give them any input other than just like, other than just like fixed syntax that we type in here, they wouldn't be that useful. We probably want a way to be able to take, parameters that a user can give us. And that's where we get into these macro meta variables. So I've stolen this big list here from the reference, and it shows us all the different sort of meta variables that we can use. I believe I have this open, the reference here, right? Macros by example, yes. Here's the big list, great. And so if you actually want to take in a parameter, one difference in Rust is that you actually need to tell Rust what kind of piece of syntax to expect, right? So for example, we might ask for an expression, right? An expression might be like, an example of an expression might just be like 42 is an expression. Or say like 42 times 10 plus 5 is an expression. Or like calling a function foo is an expression. Or like my vec here, just like referring to this existing variable my vec, that's also an expression. There's all kinds of expressions in Rust. Even a block, right, can be used as an expression because the block will implicitly give back the last thing. So an expression is something that like evaluates to some kind of value, whether it is just itself a value or if it's a more complex thing that, gives back a value, later on. What else could we expect? We could expect something like a type, right? Like I expect, when you call this macro to give in like i32 or like string, right? Something that actually needs to be a valid type potentially. Maybe some sort of identifier, like foo or bar or baz, right? What other interesting things are there? A lifetime token, a literal potentially, statements, right? A statement being like an actual line of code, right? A line of code that someone might choose to type. A block, right? Specifically a block with the braces and everything. Also this one, token tree. Token tree is pretty interesting. A token tree is like any token. It's like really like match basically anything. But the gimme is like the catch here is that if I typed in like this, right? Like let's say it's the macro is evaluating this and it goes, I expect a token tree right here. And there's like a whole bunch of stuff in here, right? It's not just going to give me back one token like it might otherwise. Like say i32 plus 5, this is one token, this is, this is one token, this is one token. But if you have, like braces or parentheses or square brackets or something like that, the token tree will be this whole thing here. There's all these different types of things you can use and have a look at and play around with. But we only need the simple ones for like where we're going at the moment. So in particular, the ones that like you'll end up using quite a lot from what I found personally is expa. Expa is used all over the place. It's like probably the most common one that you'll end up using. And then less common things like type, ident, are still relatively common. Block and statement, sometimes appear around the place. And then token tree, when you're doing some pretty advanced macro stuff, will inevitably pop up. And the rest are a little more specific, and you can probably, push to the wayside a little bit, especially when you're getting started with it all. Okay, so we've decided that we want the item that the vec takes in to be an expression, let's say, right? An expression which can be all kinds of different things, right? It could be a literal, it could be an array, it could be a tuple, a struct, there's all kinds of different things that an expression can be. And the way that we denote that with macro rules is you prefix the thing that you want to be a meta variable with a $, right? So it says that don't actually look for the syntax item or the syntax like $item. Instead, this is something special, and then you use a colon to tell Rust what kind of meta variable it is. In our case, we want it to be an expression, right? Now, down here, I can substitute it into the vector by referencing it as $item down here. So $item is going to be some expression, So this branch should be taken if the user provides basically any expression. And then we push that item into the vec by like down here. And so if I say a vec of 42, let's see what cargo expand tells us. And again, cargo expand is genuinely the best. We use all over the place. You'll see it substitutes this, right? 42 here is item. It pushes this item in. You know, it's as we expected. And because again, expressions are really flexible, you can do all kinds of stuff in here. I can say it's a block that says like let x equals 42, x times 7 plus 5. This is all still just one expression because a block is an expression that has, you know, some statements and an expression at the end in it and all that. It's all nice and very flexible, and it puts the code together how we'd expect it to. Remember, it is still substituting code, syntax code. It's not running this and then putting it in the vec when, you know, when the macro is being worked on. The macro creates this code, and then when we end up running the program, it actually does the calculation and like inserts it into the vec. I probably should have included some kind of println in here, my vec, like that. And it actually, you know, goes, oh, that's 299, or, you know, a vec of 299. Great. So this seems to work, but the problem is it currently doesn't really scale. In that if I say, let's go back to the simple example of 42, let's say I want 43 in the vec as well, it goes, hey, I don't know what to do with a comma here. Like I was with you while we were here, you threw a comma in, and I don't know where to go from here. All right, 42, 43. And so like, how do we deal with that? Well, we could just sort of like try and manually do this as best we can. Let's say item 1 here, item 2 is then another expression. And then we're going to say push item 1, push item 2. And, you know, that'll get us, sorry, I should have done a cargo expand. And that'll get us, you know, a little further along the way. So now we can deal with no items, 1 item, 2 items, but then, you know, 3 and upwards, we're sort of screwed again. And so this obviously just isn't a very scalable solution. Fortunately, macros allow us to do things such as repetition. So what we'd really like to say is any amount of items here is okay, and they're separated probably by commas, like a normal function call. So we'd like to say like 42, 43, 44, so on and like, you know, so on and so forth like that. And then for each of those items, call vec.push right around here on them, you know, in that order. So if we go back to the reference here, it should say somewhere repetitions here. And you can read all about this and all the different kinds of repetitions. But it's worth knowing that basically you can say how do you put this? You can say, I would like to repeat this thing. You can optionally say if you want it to be separated, like if you want individual elements to be separated by whatever. And you can either choose for like 0 or more repetitions, 1 or more repetitions, or 0 or 1 repetitions. Those are your 3 options in terms of repetitions. So 0 plus, 1 plus, 0 or 1 are your 3 options here. So what will we do here? We can say 1 or more expressions is fine in this branch here. And I can write that like this. So I do $parens in this case to indicate that there's some sort of repetition going on. I keep the item expr here. And then at the end here, I optionally say what I'd like them to be separated by. In this case, we'll say I'd like them to be separated by commas, right? And then I say what kind of repetition I'd like, either 0 or more, 1 or more, or 0 or 1 here. And we're going to say 1 or more. And so that works out. So essentially the way to read this is 1 or more expressions, each called item, separated by commas, right? And then this doesn't work down here anymore because it's like item is still repeating at this depth. Like, I don't know what you want me to do with item here because item is actually a whole bunch of expressions. I can't just throw a whole bunch of expressions in push. Like, tell me what you want me to do. And the way we tell it is we just throw sort of this same syntax down, where we say, repeating like that same 1 or more times inside here say vec.push each item. Right? Like it's very much sort of, you can read up on all the rules yourselves, but it's like pretty like vaguely intuitive in that you don't need a whole bunch of like crazy extra syntax in order to make this work. It's sort of just like I don't need to say repeating for like $item in, you know, that thing up there. It's just sort of like, you know, that same one or more times push each individual item. And we'll see here that this, you know, expands to what we'd expect it to, 42, 43, 44. This one here. You can see it's now sort of like scaling to as many things as we want. That's great. We can probably get rid of this double one here and this stuff down the bottom now. So yeah, again, what we've got is if there's no code that they've provided us, then just spit out vec new. Otherwise, we can have one or more items separated by commas. Each item is an expression, and we'll turn it into a block that says let mut vec is vec new. And then that same, like for each of those items, push that item onto the vec, give the vec back. And you'll see that's the code that ends up expanding into. But doesn't it expect the list of elements to end with the comma? So actually, specifically the opposite. If I had to put the comma here, then I would be saying one or more times expect there to be an expression and then a comma. And you'll see if I save this, it's going to go, hey, you're missing some extra tokens that are required, and it requires that extra comma at the end. When you put the comma here, just before like how many times you say it repeats, this is signifying to macro rules that you would like these things to be separated by commas, right? So each individual iteration of this should be separated by a comma. And so it's sort of smart knowing that, well, this is separated by this by a comma, this is separated by this from this by a comma. But there's no additional thing here, so there's no comma needed. But the sort of drawback that comes with this is that if I put a comma on the end, suddenly this macro doesn't work because I've got a comma sticking off the end here, and it isn't expecting a comma. You know, if I put a comma in there, now this works, and then I take the comma away, and now it doesn't work. And so, you know, it's a little bit of a tricky problem for us to think about there, which is going to be this very bottom example that we'll talk about in a minute. But yes, like well noticed. Cool. So that's sort of like our baseline vec macro. Let's see how it's going in our tests. So I've just got, here's like testing it against the standard libraries vector, empty, 1 element, 2 elements, 3 elements. I'll say, guess we go cargo run, and it seems like there's no failures here. Just to check it's running it, if I change vec1 to vec2, you'll see that's no good. So it is running those. It seems to be doing the right thing. Why isn't it designed in a CML style? You're going to have to help me along with that. In a CML style. Yeah, you'll have to help me with that one. Rust will automatically expect anything within repetition to be of the same type. It'll expect anything in the repetition to be... So no. That's an interesting idea. Is like, what if I give it 3 wildly different expressions? Right? Like I give it one... let's do it up here, actually. 42... string 50.5 and then like crazy expression, like I don't know, like a tuple of like 42, 40, 50 and hello, right? All these different kinds of things in here. If I go cargo run, then, you know, obviously things aren't working. But if I ask for cargo expand, and I've got a whole bunch of junk here now. If I ask for cargo expand, you'll see the macro expands just fine, because all it's asking for is that these are expressions. And so it sees that, it goes, do this, do that, do this, do that. And it's only once this code is run through the compiler, right? It's only once this code is run through the compiler that then it sees a problem with it, because it's going, hey, you're trying to, you know, push in types that just don't make sense. Expected integer found floating point number. So it's actually like this step strictly comes first before all this like type checking, you know, before types are really even considered like that. So that's an interesting sort of, you know, consequence of macros. Oops, that's not what I wanted. I wanted to do this. And then, command line argument style. Command line inline argument style. Oh, do you mean in terms of like, why didn't they specify this the same way? Like, why are they sort of using this syntax here that's like a little regexy and a little weird? I'm not sure why they chose this exact syntax, but you know, Rust has its own needs and stuff, and I suppose they settled on this being, you know, relatively good. But yeah, there's certainly an argument to be had there in terms of what's the like best syntax for something like this. Definitely. Right, so all these seem to work, but there is this one test case that I've got down the bottom here that, based on that previous discussion, actually won't work. Where sometimes you like to specify, you know, your arguments, let's say vertically like this, and it's nice to be able to provide a trailing comma if you would like. Whereas with ours, it's not expecting that token, and so it just simply doesn't work. So notice it does compile for studvec, but doesn't compile for our vec here because it's not expecting that comma. There's a relatively easy fix for this, and there's, you know, there's a whole bunch of different ways that you could choose to do this. But, you know, a relatively simple way you could choose to do this is just say at the end here, optionally allow a comma if they'd like. All right, just optionally do that. And recall that there's a repeater here, which indicates an optional fragment of 0 or 1 occurrences. And so I can just follow the same syntax, excuse me, of $bracket question mark, right? Like I did here with like $bracket comma plus, right? There's no separator for an optional fragment because it's not repeating. And then inside here, what sort of tokens, what syntax am I saying is optional? Just 1 comma, right? And notice that whitespace also, like whitespace, the actual sort of tokenization comes first before we get into the macro system. So things like whitespace don't matter, right? I can put a whole bunch of whitespace here and the macro rules doesn't care because it's already been tokenized before that point. And so now this trailing comma is fine because it parses all of this as like the main stuff. 1, you know, separated with a comma from 2, separated with a comma from 3, separated with a comma from 4, separated with a comma from 5. That's the end of that list. And then it just sees a comma and it goes, great, that's the optional comma there, which just doesn't end up getting used, essentially. So yeah, that seems to work as well and is certainly an option. So this is pretty much our vec macro completed. Very epic. So what else did I have? Right, yeah, so we've got some more stuff to look at naturally. But this is our vec macro. And this is sort of like, if you understand all the bits and pieces that are going on here, you're like well on your way with macros. We're going to write one more macro, which is pretty cool. We're going to write one more, and then again, I'll show, it'll mostly just be showing code past that point. Test vec. Now that one goes here. Cool. Don't need the to do anymore. We actually did it. This here is vec bang of, you know, 1, 2, 3, you know, so on like that. Great. Alrighty. And this one here is just that, which I guess we don't need anymore. Okay, so are there any questions with the vec macro before we, well, I'll show the C macros converted into like Rust style macros, even if they don't really make a ton of sense in Rust itself. We'll write one more macro and then we'll look at those very cool proc macros that I promised. But are there any questions with what's going on here in terms of our like homebrewed vec macro that we put together here? Crab emoji. All right, if you're typing out a question, then please continue to do so. I'm going to flick off it for now and move on to the next thing. But again, if you've got a question, you're working on typing it out, continue to do so and we'll jump back to it. Let's have a quick squiz at these C macros we looked at before converted to Rust. So in the case of max, the macro rules here I think is relatively simple. So macro rules max, where we just go $a, like we take in $a as an expression, $b is also an expression, and then this turns into the code if $a is greater than $b, then $a, else $b. Right, and so if let me turn on the test for this one. If I run this, you'll see that it says max of 40 to 100 is 100. So that seems to work out. And if I cargo expand this, oh, I didn't uncomment the vex stuff. Max. Yeah, well, you can see this is where it got spat out. It's also inside another macro, which is the debug bang macro, which I really like using, but it is very, like, it's a bit of a crazy macro. But you can see here, this is where our code itself got spat out. Oh, the if as well. This, 42 was A, 100 was B, 42 was A, 100 was B. And so it's substituted the text as we'd expect. But note that this does still suffer from that same problem, which is if I have, say, some function, print and return, takes in some I30, or let's say print and return of t, where t is can be printed out. X is some t, we give back that same t, right? We've learned generics, we know how to do this. So I'd say print out x, and then give back x. And I do the same thing, print and return 42, print and return 100, cargo run. You'll notice that, Rust this is still like a pretty fundamental, like, problem in air quotes, like a pretty fundamental idea in macros, in that this is sort of like your expectation in terms of if you wrote a macro like this, you'd expect it to do that because it's just substituting the code like this. However, in Rust, because we have block expressions, we have some opportunity to get around this in terms of doing something like let A be $A, let B be $B, and then if A is greater than B, then give back A, else give back B. So why does this help us at all? If I do cargo expand again and try and track down that little bit here. Where is it? Here we go. Right, now it spits out this code here. Let A equals print and return 42, let B is print and return 100, and then just does the comparison there. Right? Yes, and Dong has do while 0. Yes. Very, very, very true. But you can see that now we only call the function like once for each parameter because we can just like bind it and then give our thing back in an expression return. So it's a nice little solution if you only want it to be evaluated once. In Rust, you might do something like this. But yeah, so something to be aware of, something to know exists. But I'll leave it as the C macro was in this case. The up to looks a little like this. We have, in Rust, I can't just go like, remember in the C code, it just left the whole body of the for loop out. And then we just put like the for loop after the macro invocation here. It's like kind of a little crazy like that. Rust isn't going to be super pleased about just spitting out code like that, sadly, with the macro system. So instead, we'll take the body in here. We'll take the body in as an expression, or this could, I suppose this could probably be a block as well instead. Maybe a block makes a little more sense. And then we just go for, take in a identifier, in this case, I being the identifier that we'd like to use in our loop. Maybe you'd like to call it foo and foo, whatever you want to call it. N being an expression of what we're looping up to, and then the body of the code, which is just a block. And this turns into the code for, in this case, like foo, we've called it, for foo in 0 up to 10, right? Then spit out this body, println foo. I can try and look for this one as well. Hunt it down. This is sorting up to, there we go. For foo in 0 to 10, right? For foo in 0 to 10. The body here, and the body ends up just calling println. Println is also a macro, as we know, because it lets us do this sort of clever stuff like this, like format strings and all that. So that's the up to macro in Rust. And then the sort macro, which is naturally a little crazy. I'm not going to go too deeply into this, but it's there on GitHub if you'd like to have a look at it. Again, usually we just use traits in Rust. Like we would do it if I want to sort something. We look at like how Rust has done it, where it says to sort a slice, you just have to require that the elements T inside that slice can be ordered, and then if they can be ordered, it'll just merge sort it using whatever their implementation of ord is, where you can compare two things and spit out an ordering whether they're less, equal, or greater. And so we wouldn't wouldn't really write code this way in Rust, but you'd still have that option available to you. And sometimes, very specific requirements might mean that this might be the way you have to do it. But it's there for you to play around with and to ask questions about on the forum if you would like to. Okay, so let's write our one last macro. In fact, I'm going to do what I did last time and copy paste it into main, which is C4. C4. Not C4 the explosive, but I'd like to, this is like this idea of syntax extension. Maybe I've come from C and I really, really like the C for loop syntax, right? I like the for blah, blah thing, blah thing, blah thing, and then the body of the for loop in like this 3-part initialize, condition, step kind of syntax. There is no equivalent for that in Rust, but worry not. We can do this with a macro, even just with a declarative macro, a macro by example, using macro rules. We don't even have to go to the whole procedural macro land and get all crazy with it. So how would I write a C4 macro? Well, first of all, we need to specify what kind of input we're expecting to the macro. And then got to decide what kind of code would we like to spit out from the macro. So what kind of input are we looking for? Well, we're expecting them to put a for loop in, right? So a for loop starts with for, F-O-R, right? So I'll type that in. Then we expect some parentheses, right? C requires the parentheses on its for loops. Then we, first of all, we'll get some sort of statement, right? Like something to do before the for loop starts. That's a statement there. So we'll call that $init is some kind of statement. Then we expect to see a semicolon here. We expect to see a condition. The condition here being an expression, something that will, give us back a true or false value. So I'll call it the condition here, condition, and it's just some kind of expression. And then finally, we end off with another statement, no semicolon at the end of this statement though, which is just like what to do at the end of each iteration. So I like to call this the step, and that's just some kind of statement like this. Finally, we expect to see the parentheses end and the actual body of the for loop, which as we saw before is probably best expressed as a block. So the body here is then going to be a block, right? And you can see the fact that there's no errors means that this parses, right? Let's say I just turn the code into like the string hello, right? Just to like test what's going on. And I run cargo expand main. Nope, cargo expand test C4. There it is. You can see it's matching all these tokens as I've written it here because it's turning all that code just into the code string hello. So it's working. Now it is working. We just need to make it actually do a for loop, right? Do the actual looping that we'd expect. And so what code should we put here? Well, we probably want to put here like how I would explain a for loop to a new C programmer. The way I tend to explain a for loop to a new C programmer is we have a few parts. We have the initializer, we have the condition, we have the step, and then we have in here the body. And a for loop, at the end of the day, really just is like the initialization while the condition, the body, and then the step. That's generally how I choose to, like, how I'd explain to a beginner, this is how a for loop works. It's just a while loop that looks like this, right? If we like substitute the actual tokens here that we've got, it's going to look like this. We're going to throw the condition into the while loop here. We're going to throw the body of the while loop, which is this, in here. And then we're going to throw in the step at the very end there, right? And essentially, the explanation of how I just did that is all I need to explain to the macro. So how am I going to explain it to the macro? I'm going to say, well, first of all, like, do whatever the initialization statement is there. So throw that there first. Then, next up, we're going to do a while loop. And we're going to while, our condition is going to be the condition that they specified here, right? While the condition. Inside that while loop, I would first like to do the body that they've provided here, right? So throw in the body that they've given us. And at the end of the while loop, whatever like the step that they gave us, what was here, this I plus equals 1, right? And so like, I'm not kidding. That's it. That's all the code. Cargo expand, and you'll see, I mean, the print line here is maybe a bad choice. If I just comment out the body for a second, you'll see we get let mute I is 0. While I is less than 10, the body goes here, I plus equals 1. Right. The println macro again throws in a bit of like some extra stuff here, but that's just like the body of the thing. Right. And then like, yeah, like I see saying something about continue or break or whatever. You could even use continue. You could use break. Like all of these will work because we're still in a while loop at the end of the day, which is going to function like the same way. And so let's run it. I probably need to call it test C4, and you get 0 through 9, as we'd expect. Right, pretty cool. So this is the kind of thing, if you really like these for loops, if you really like this syntax, then you can bring that syntax into the language. Right, so we've seen like convenience things here, right? This is more of a convenience macro in that it helps you, like very commonly you might want to create a vec with some like predefined elements, and writing like vec push is really rather annoying, and functions, as we know in Rust, can only take a fixed amount of arguments. There's no concept of variadic functions in Rust, but with a macro we can bring back that convenience, and you know, also with macros we can do even more like interesting stuff in terms of introducing additional syntax to the language, for example, with something like a C4. And you can see when it's a relatively simple idea, a macro rules can also just make that very easy. And like, sure, you might look at this and like, it might take you a minute to figure out what's going on there, but it's pretty readable in terms of like, if you know the syntax and you know how these macros by example work, you can probably read through and go like, oh, I get what's going on here. Oh, actually, that's a good point. Using continue needs to jump to the step, not back to the start of the loop though, so continue might not work. That's a very good point. That's quite interesting. And so there might be like tricks that you need to, in fact, you could probably just do a, there's some tricks that you might need to pull in order to make that work effectively. I think I could come up with a hacky way of doing it on the fly, which is maybe something like, but then you have to worry about continue and not break. Yeah, okay. I think I could do this, and if you ask it on the forum, then you can certainly bully me into doing it. If you're interested in it, you can ask on the forum. But it's probably going to involve like throwing in like a fake pseudo loop in here, and then using like the continue or the break of the pseudo loop to inform what you want to do in the outside loop. That would be my intuition of the primary way to do it. Or alternatively, you could just have a look. Like this idea is not exclusive to what we've seen here. Some people like C4 loops. Nope, not C4, C4. Right. This is a, they don't do it in the exact same syntax that we've got here, but you know, other people have come up with this. And handling continue. Oh, this is bad C4. Warning, this is broken. Yep, exactly as you say. So they've got this example here, which I wasn't aware of. And then they don't actually tell you how they do it. But I guess we could look at this, and then we could see, yeah, they have like a cheeky extra loop in the middle here, is what I was expecting. First and continue, they put the body in probably here, yep, and then they use that to inform what to do in the bigger loop. So the macro is a little more complicated because of that. Oh, and also you can have as many initializations as you want. I actually forgot about that part of C as well, and they deal with that here. But yeah, there's all kinds of stuff that you can play around with. Have a look at this macro, docs.rs/c4, for sure, because there's clearly some interesting stuff going on there. All right, so that's our C4 macro over there. Let me throw it back in where it should be going, which is here. Great, main, throw out this, and I can uncomment all of this now for you to use in when you're playing around with the lecture examples. Yes, macros are very cool, but naturally they can absolutely be abused. There is like a certain, you know, sort of, I like to talk about macros similar to how I talk about regexes, in that a lot of the time you have a problem, you write a macro to solve the problem, you now have two problems. You know, in that macros can often, sometimes they can create more headaches than they're worth, but they also open up a lot of really powerful possibilities. Okay, so 2 quick examples. Are there any slides? Is there any information that I've... Oh, right. Yes, there is something I want to talk about. So the C macro translations, the C for loop, we've done that. Okay, 2 things left. We might run a little over. MacroKata and the proc-macro showcase. So MacroKata is a set of exercises which you can use to learn how to write macros in Rust. There is, I think, 12 exercises, because this isn't actually an exercise. There's 12 exercises in MacroKata, and they start you from like writing very simple macros all the way up to, quite more complicated ones. And in the weekly exercises, the weekly exercise repetition is simply exercise 6 of MacroKata. So you could jump straight to exercise 6 if you're feeling very comfortable with macros, and we're not marking your progress on 1 through 5, but 1 through 5 will help you also build up the knowledge yourself in order to complete exercise 6 that we're marking. And then furthermore, we also have exercise 11 of MacroKata as a challenge exercise. So you can continue going on all the way up to exercise 11 to get this currying example, which is certainly more complicated, but can do even like cooler stuff for sure. So I would suggest going through MacroKata yourself, follow the instructions and work through it in your own time, and ask as many questions as you'd like on the forum and all that. It's a great, and yeah, Tom wrote this. Very big thanks to Tom. It's a very cool set of exercises. The marking for challenge exercises, it says something like where'd it go? Where is the mark? There was something here. There we go. It is a challenge exercise, and if you do not complete the exercise, you will only lose a small fraction of course marks. So they are like worth marks, but probably not as much. Yeah, like, and we're making it very clear that these are certainly challenging. Great. So MacroKata, an amazing set of exercises. I would suggest just going through it and seeing how far you get on your own. No need to skip the first few or to stop at 6 or whatever. Just go through it, and if you get stuck somewhere, then come talk to us, and then you'll just be able to submit the ones that you finish on the through the course exercises, the weekly exercises, right? And the other half of the exercises are about function types, which we're going to be talking about on Wednesday. So MacroKata, and these also link to macro. That's spelt incorrectly. Link to MacroKata spelt incorrectly. So yes, massive props to Tom for putting together this practical, almost like self-guided workshop in becoming familiar with macros. All right, last bit is just a quick showcase of some really cool stuff you can do for with macros. These are all going to be procedural macros, which are the kind that like are general purpose Rust code that can do, where really the sky is the limit in terms of like just write a Rust function that takes tokens and spits out tokens. It means you can like, as part of a macro, you could do all kinds of crazy side effects. You could like ping the internet. You could go fetch something off the internet. You could read the file system. You can do, it's actual Rust code. So with a proc-macro, as part of the macro expansion, you can literally do anything and spit out like literally any code. Makes them also a little dangerous, a little scary as well for that reason, and opens up a lot more avenues for abuse, but it also opens up a lot of avenues for really, really cool stuff. So the 2 I'm going to show you is, first of all, something called Yew. Oops. It's showing results for years. Not quite what I want. Okay, fine. Yew.rs. There we go. So Yew.rs is a web framework written in Rust. So Rust can compile to something called WebAssembly. WebAssembly is code that can run in a browser. It can also run outside of a browser, but the original kind of primary intention was to run in browsers. And so you can actually write Rust that runs on a front end. Like this website, I haven't, actually checked this myself, but I'm assuming this website here is probably written in Rust. If you've done 152 in the last couple of years, or, you teach 152 or whatever, you'll be familiar with something called MipsyWeb, which is, again, a Rust application that runs in the browser through something called Yew. Now, how do you get a Rust program to spit out HTML that you can see that you can see and interact with in your browser? Through a macro. So this is one of the straight up most brilliant inventions to come out of the land of Rust metaprogramming is the HTML macro. And the HTML macro lets you just basically start writing HTML code in a Rust file. If you're familiar with things like JSX from React and stuff like that, it's a similar sort of idea. I'm literally writing HTML code in here and mixing that in with Rust code. I can say, when you click this button, print out button clicked, right? The text of the button is clicky button. I have a hello there is a paragraph, and then here's an A tag which says here's another message with some bold text in there as well. It's just seriously cool. And if we use cargo expand once again, udemo cargo expand, you'll see this is a little wild at this point, but the my HTML, this turns into Yew virtual DOM vnode, and it's actually turned into a whole bunch of Rust code, right? A whole bunch of actual Rust code that represents this big tree of HTML. It also means that if I say screw up my tags, let's say I actually accidentally wrote buttons here instead, and then try and compile the code, you'll see that this closing tag has no corresponding opening tag, right? / button here doesn't correspond to buttons there. And this is the Rust compile, part of the compilation of the Rust code that's getting us this. We're getting all the checks and guarantees and all that the Rust compiler gives us, but now sort of pseudo applied to HTML, which is just I personally think is insane. It's incredibly cool and very powerful. And so this is the basis of, of things like MipsyWeb or, just Rust code in general being written in a web browser. And you can certainly get a whole bunch of, guarantees around reliability, robustness through stuff like this, which is seriously cool. The chat, let me catch up. Small question from last lecture from traits. Is there a way I can have a default implementation of a function defined in the trait? Yes, just to quickly explain that. Trait, foo, function, foo, you can actually just provide a default implementation inline like this. Let's say my default implementation is it's foo time, right? This will now be the default implementation for anything implementing foo. And yeah, you can't assume anything about the type of the trait, as Simon mentions. Yep. Probably more to do with inheritance of traits. I want a subtrait, so if a struct implements the subtrait, it'll get the default implementation, but otherwise it won't. This is probably getting outside the scope of the lecture, but if you ask on the forum, I'll be more than happy to have a look at that for sure. But yes, this is I think this is very cool, and it's all thanks to the power of macros that we can just put in actual checked HTML code in here. There's one more to look at, which is this SQL demo here. So this is a library called SQLX. SQLX is very cool. And if you're familiar with databases vaguely, I've got a database here, test.db. It's basically just a database that contains, some it's probably easier if I just show you what the only thing in the database is. It's just got first name, last name, email, phone number. That I've just created a random database to show this off. And this SQLX is a library that lets you query databases, and they use a macro for this, SQLX query bang, right? And I type in my SQL here and, ask it to do the work. If I say cargo run, you'll see it spits out a record with this information in it. Now, what's good? Like there's nothing that impressive going on here. Most languages have some sort of like SQL framework to help you talk to a SQL database. What's really cool here is that every time I build the code, you know, this is configurable to be clear in the SQLX library, but you know, the way I've got it set up, when I build my code, it will actually test this query against the database. First of all, it'll make sure this is actually a valid SQL query, but it'll also like actually test it against a database and make sure that you're not like, you haven't say typoed anything. So let's say I do like last nam instead of last name, right? And I build the code. Look at this, compiler error. No such column last nam, right? It actually goes and queries a test database to make sure that like this SQL query is well formed when I build it, when I compile the code, which again is just really cool, I think. Another thing that's going on here that's not super clear is that usually in Rust, I'm going to have to like say what, you know, what type it is. I'm going to have to, you'd imagine I'd probably have to do something like struct record has like a first name is a string and a last name is a string and so on. And then use something like serde to do something like derive, serialize, deserialize, that kind of thing. Another thing it's also doing is it's looking at my SQL query and generating me a struct that looks like this record, like automatically for me as it's building the program. So you still get all like the type safety and everything. So like the compiler knows that say account.firstname exists and account.foo does not, but you don't have to go and write all the structs as well. So another just really awesome application of macros to make programming more robust and potentially easier. Very real phone number, time to create code that sends Zach Ferris's every 10 seconds. Can't you write any languages in Rust at this point? Yeah. So like, I know Mara has written a Python in Rust. No, not PY03. No, Python macro in Rust. Yes, mouse. Inline Python. There we go. So this is a thing that someone called Mara Bos has written, and I think has a blog post about, explaining how they actually went and made it. But here's a Python bang macro where you can just like write Python code, and it will spit this into a Python interpreter, which is just like, again, I think so cool. And people made all kinds of different languages that you can just embed the syntax into Rust. Quite unlike the phone number that they read out of the med show. Oh, oops. Write C that writes Rust that writes C. That's nuts. Write code that emails Zach the compiler every time you compile your code. Yes, would be possible if you threw it inside a macro. Prefer Piccolo's method of doing queries where it represents the entire database in Python, so I get the benefit of static analysis for type safety without needing the DB for it to be initialized. So you don't, there's many options with SQLX as well, to be clear. I've set it up to live query against this SQLite database, but you can actually just sort of specify this, it can infer the schema of the database and store that offline, and just do static analysis without a live database to query against. So you have that too. Type safety on the return is nice. Did Rust Analyzer see the type? I don't think so. Rust Analyzer, this is like, I think it's feasible that one day Rust Analyzer might be able to tell you, but Rust Analyzer sometimes gets a little confused. Actually, no, Rust Analyzer is just not running in here because it's confused about, I've screwed up the whole workspace situation going on here. We can check at the very end if Rust Analyzer, like what Rust Analyzer does in a case like this. Can it do with SQLite or with any other DBs? A whole bunch of DBs that it supports, yeah. Rust, the one and only language. Piccolo's doesn't even use a schema. It generates the schema from the classes you create. Yes, I believe that's possible. You generate it from the models as well in SQLX. So I think you could specify the schema yourself, or it can generate the schema from the models that you type into your program if that's the way you want to go about things. So there is lots of options as well. Cool. But yeah, just like, again, there is almost no limit to the kind of crazy stuff that you can do with Rust macros. When you're going really crazy, you usually have to step up to that level of proc macros. And they can, again, be quite tricky to write. but I think the book has a relatively simple example of a proc macro. Yeah, this might be worth just quickly showing you all, in that they write a macro that looks like this. It essentially goes, so it takes in, a stream of tokens and spits out a stream of tokens. And what does it do? It goes, well, grab, like they're specifically writing a derive macro. So it's expected that this is going to be, you're going to be putting derive on a struct or an enum or something like that. And so it says, grab the name of the struct or enum and then spit out the code impl hello macro for, that macro's name, which, does this. This could have been done in the macro rules. Oh, it couldn't have because it's a derive macro, but you could make a macro rules that does the same thing as this. I guess maybe not though, because it would be tricky to turn that string. Oh no, stringify would still work here in a macro rules. So you could do this with the macro rules, but you could imagine between say here and here, like on, between these lines, you could do anything you want. You could literally, again, like fetch from a website, grab like the joke of the day and then put the joke of the day in the code like this. That's probably a very bad idea, to be clear. But you could, right? And this is, in our cases, this is where Yew is, checking all the HTML, or SQLX is running the query against a database to check if it's okay, and all kinds of stuff that you could do in here. But yeah, so that's, I think, mostly what we wanted to talk about from the SQLX, GitHub, Postgres, MySQL, SQLite, and MS SQL. Great, very cool. Yeah, so that's basically it. Naturally, if you have any questions, as per usual, then feel free to ask them now, but we'll call this the end. I'm going to try and like spit this into its own workspace so we can see that question about what does Rust Analyzer do with all this. And I can do that like this. Sure. Let's see what it does. Yes, I trust. Rust Analyzer is waking up. So any questions? I can make the compiler to randomize an insult every time my code doesn't compile. I think someone did that. What was it again? It was like, I can't remember. I think someone did that though. Have a look for it. If you can find it, put it on the forums. But I remember this like from maybe a year ago or so. And doing it as a macro would be entirely unnecessary. Oh, cool. Okay, so it sees that it has the type record. It can't find the definition of it, obviously. It's just pointing us to main because it got generated by the macro. But it does see the type, and I wonder if it knows about the type. It does. How cool is that? So it's got email, it's got first name, it's got last name, it's got phone. Even though I never defined that anywhere. Never defined it anywhere. So that's like, chef's kiss. Like that's pretty cool. Anyway, macros are pretty cool. It does work. It's just like, naturally cargo workspace stuff can get a little, sad at times. But yeah, very, very awesome. So any other questions? I suppose I'll switch to actually, let me, I'm not sure if this is pushed up to Git yet. I'm assuming it's probably not. Untracked. Oh, .. right. It's hiding here. Sure. That looks about, yeah, we need that. Yep, that looks right. Black 11. That code is now on GitHub. You can write a macro to make the compiler play crab rave when your code compiles. Yep, you could. Have the marks for Christmas tree exercise and Pokédex exercise been finalized, by the way? They have been marked and they should be released. There might be problems with that, and if there is problems with that, let us know and we'll try and fix them. If you mean finalized in the sense of like the mark doesn't look like you think the marking wasn't, you know, entirely representative of the work you put in, then it's just like reach out to us. A lot of the time that's just like an auto marking thing where it's like, oh, it was off by like a couple characters, but I, you know, or I got like halfway there, but it gave me 0. And we'll go, yep, that seems fair. We'll give you, you know, we'll give you 50% because you got halfway there. Oh, it was just like a character off. We'll give you 95%, you know, like that kind of thing where it's just send an email if there's a problem with your marks. What if when you get a compiler error, it automatically opens Stack Overflow with the error message in the search? You could probably do something like that too. Indeed. Yeah, people have done stuff in terms of like when the compiler does blah, do some other thing. There's all kinds of fun, crazy stuff that people have done. So yeah, go looking for some crazy Rust macros and throw them on the course forum because I'm sure everyone would love that. Yeah, any other questions? Any other questions? I'll switch to a Ferris background. I'll give us another 30 seconds for any last questions. It's looking quiet. Sort of video, someone programming C. Oh yes. That would be a scary one. All right, I'm gonna say there's probably no more questions. As usual, ask as many questions as you like. Please ask, you know, plenty of questions on the course forum, and we'll get around to them and answer them when we can. And yeah, thanks everyone for coming. Hopefully we had some fun with macros today, and we'll be back on Wednesday to talk about functions and closures. And it's gonna be tricky, but it'll be fun, of course. And I look forward to seeing you all then. So I'll see you on Wednesday. Yeah, enjoy continuing working on your assignment. Ask any questions that you come up with on the course forum, and I'll see you all then. So thanks everyone, and catch you later.